In the list of 8 planets, Mercury is often the name skipped. It doesn't have magnificent rings, nor the fiery promise of life. In many eyes, it's just a roasted rock, a dry, dead, and boring remnant. But brace yourself. What you are about to hear will shatter your prejudice. Imagine a world where a day lasts longer than a year, where you could freeze to death, even while standing next to a furnace. Welcome to Mercury. Today, we dissect this iron cannonball. The more we learn, the more we realize how wrong we have been for decades. First, let's talk about temperature. Mercury is the closest to the sun. It endures massive radiation. At noon, it hits 430 degrees Celsius. That's hot enough to melt lead right on the ground beneath your feet. But what happens when the sun sets? Mercury has almost no atmosphere, no blanket to trap the heat. As soon as night falls, the temperature plummets to -180. That's a swing of over 600 degrees, the most extreme in our solar system. It's like jumping from an oven straight into a tank of liquid nitrogen. NASA's Messenger had to be tough. It used a ceramic shield for protection. Now, let's look at time. Mercury doesn't spin like most planets. It has a 3-2 spin resonance. It rotates 3 times for every 2 orbits around the sun. This creates a bizarre cycle. One solar day lasts 176 Earth days, but its year is only 88 days. Think about that for a moment. A day is twice as long as a year, and because the orbit is an ellipse, orbital speed changes constantly. At its closest point, it moves faster than it rotates. If you stood on the surface, you'd see the sunrise, then stop. It would move backward for a while, then change direction once more. A double sunrise is real here. Pure physics at the absolute limit. Now, look deep inside. Mercury is an internal monster. Earth's core is just a small part, but Mercury's core is massive. It takes up 85% of the radius. It's more like an iron cannonball, wrapped in a very thin shell of rock. Why does it look like this? Science has been debating this for years. Did a giant impact blow its shell away? Did the sun evaporate its outer layer? Or did it form somewhere else? Messenger found a huge clue. It found sulfur and potassium. These elements evaporate in high heat. If a collision happened, they shouldn't be there at all. So we are back to square one. Mercury holds a secret about how the solar system began. Now, at its skin, Mercury is like a shriveled apple. As the giant iron core cools, the entire planet shrinks. The rocky crust is brittle, so it cracks and buckles, creating massive V-shaped cliffs. Some are thousands of kilometers long. Some are taller than mountains. And this is still happening. New cracks were found recently, only a few million years old. That's yesterday in space-time. Mercury isn't a dead rock. It's still active and changing, rippling with Mercury quakes. Next, look at the hollows. Strange, shimmering pits. They are blue and rimless. The planet is literally evaporating. The sun's radiation is so strong, it turns minerals into gas. The ground then collapses, creating these bright, alien pits. It's vanishing before our eyes. Now, the magnetic field. Small planets shouldn't have one. Mars and Venus don't. But Mercury does. Though it's very lopsided. It's pushed toward the north, exposing the South Pole to the full fury of the sun. And the biggest shock of all? Ice in the furnace. At the poles, there are deep craters, shadows that never see sunlight. Ever, in billions of years. In that darkness, it's freezing. Pure water ice stays there forever. Right next to a world of fire. Soon, we will know more. But Piccolombo is on its way. It will reach orbit in 2026 to solve these final mysteries. Mercury is a resilient survivor, full of personality and secrets. Thanks for watching our journey. Don't forget to like and subscribe. Now, let's talk about its iron heart. Mercury is an internal monster. In most rocky planets, like Earth, the core is just a small fraction. But Mercury's core is massive. It takes up 85% of the planet's radius. It's like a giant iron cannonball, wrapped in a very thin shell of rock. This shell is only 400 kilometers thick. That's less than the distance from New York to Washington, D.C. Why does the smallest planet have such an oversized heart? Science has debated this for decades. Did a giant impact blow its shell away? Or did the young sun evaporate it? Messenger found a huge clue. It found sulfur and potassium. These elements vaporize in high heat. If a violent collision happened, they should have vanished long ago. So, we are back to square one. Mercury holds a deep secret about how our solar system began. Next, look at its wrinkled skin. Mercury is like a shriveling fruit. As the giant iron core cools, the entire planet contracts. Because the rocky crust is brittle, it buckles and folds under pressure, creating massive cliff-like features known as lobate scarps. Some stretch for 1,000 kilometers, and they are taller than mountains. For a long time, we thought this happened billions of years ago. But Messenger saw something new. It spotted tiny, fresh cracks, only a few dozen million years old. That's yesterday in space-time. This means Mercury is still shrinking. It is still cooling right now, rippling with ongoing Mercury quakes. It's a world that is still active. Now, the hollows. Thousands of strange, shallow pits. They are blue, and they glow. There is nothing else like them. The planet is literally evaporating. Intense radiation hits the rock, vaporizing volatile materials. The solid surface then collapses, creating these bright, alien pits. It's vanishing from the inside out, right before our eyes. Finally, the magnetic field. Small planets usually lose their heat. Mars and Venus don't have a field, but Mercury does. Though it is very lopsided, it's shifted toward the north, leaving the South Pole exposed to the full fury of the solar wind. Why is it offset? Another puzzle for Piccolombo to solve. And don't forget the ice. Inside the darkest craters, in shadows that never see the sun, pure ice has sat for billions of years on the planet closest to our star. Mercury is a world of contradictions, the hottest and the coldest, the smallest and the densest. It's a survivor, full of mysteries. Thank you for watching this journey. Don't forget to like and subscribe. Let's dive deeper into the mystery of how Mercury actually formed. For decades, the giant impact theory was the only story that made sense. A massive object, the size of Earth, slammed into a young Mercury. It ripped away the rocky mantle, leaving only the dense iron core. This impact created massive features, like the famous Caloris Basin, one of the largest craters in the system. But when NASA's MESSENGER arrived, the story became much more complex. MESSENGER orbited for over 4 years, collecting nearly 300,000 images. And it found something impossible. The surface was rich in volatiles, potassium, sodium, and sulfur, elements that evaporate at high heat. If a giant impact had occurred, these elements should be gone, boiled away billions of years ago. Yet, there they were everywhere. This created a scientific puzzle, with no clean or easy solution. Some suggest a hit-and-run collision, a glancing blow instead of a direct hit, gentle enough to save the volatiles, but strong enough to strip the mantle. Others think Mercury formed elsewhere, in a much cooler region of space, then migrated inward over time. The truth is, we still don't know, and that uncertainty is fascinating. Now, let's look at the magnetic field. It is a global dynamo, generated deep within the liquid core. But it is shifted strangely northward, by nearly 20% of the planet's radius. This asymmetry has a major impact. The southern hemisphere is wide open, defenseless against the solar wind. Charged particles slam into the surface with much greater intensity than the north. This uneven bombardment may have altered the soil composition, creating two very different hemispheres. Mercury is also shrinking right now. The crust buckles like toast. As the interior continues to cool, new features called grabens appear. Tiny troughs, only a few meters wide. They are so fresh, they must be young. Perhaps only 300 million years old. This makes Mercury geologically alive, unlike our moon, which is truly dead. And then there's the evaporation, causing the mysterious hollows. They have no superimposed craters, meaning they formed very recently. Some might be forming as you listen. Mercury's surface is dissolving, turned into vapor by the sun's fury. It is a world of contradictions, hiding ice in the dark, while melting lead in the light. We used to think it was simple, a dead, roasted cinder in space. But we couldn't have been more wrong. The more we look, the less we know. And that's why we must go back. But Piccolombo is our next great hope, arriving in orbit in late 2026, to pull back the curtain once more on the most extreme planet we know. Thanks for watching this exploration. Make sure to like and subscribe to stay curious about the cosmos. Let's look at the Caloris Basin again. It's 1,500 kilometers wide, one of the largest impact features in the entire solar system. The impact was so powerful that shockwaves traveled through the entire planet, focusing on the exact opposite side, creating a jumbled terrain. Mountains and valleys formed instantly from a single catastrophic event. This tells us how violent Mercury's early history truly was. And what about the surface color? It is much darker than the Moon, because it is covered in graphite, the same material in your pencil. Scientists think a primitive crust of graphite once covered the planet, later buried by volcanic lava, but revealed again by impacts. Every crater is a window into the deep past of the planet. As we wait for Bepicolombo, we realize Mercury is a masterpiece of survival against the sun's overwhelming power. It's not just a small planet. It's a giant story in a small package. The Iron Planet is waiting to reveal its final secrets. Stay curious, stay inspired. The universe is stranger than we imagine. Thank you for being part of this.